Thank you for actually I'm from the Jeonnam National University. The last time I visit here, my affiliation was Seoul National University and my affiliation was changed. And I'm very pleased to be here today. Our title is The Gap Between Science Teachers' Interest and Practice of Teaching Competencies for Improving Students' Core Competencies. We have four co-authors, and me is Jee Young, and there's Professor Yu, and we have another two co-workers. And as you can see, we were supported by the Ministry of Education of Korea and National Research Foundation. So there's a big project for the supporting teachers' professional development. And we are one of team for the big project. So it's basically the uh, project-based research. And so uh, as you know, there's a big trend of education. And in the left side, you can see the well-known OECD compass. And in right side, you can see the Korean pictures for the new reform documents. Before my session, the professor said about the US educational system, but the educational system in Korea is totally different. We have the central, we have central system, and everything is top down from the government. So we have the we have the reform documents from the government, and you can see there's a competencies and knowledge and participation and actions. And these three makes and balance the scientific literacy for students. So our survey is based on this document. And before explaining about our research, I can briefly show about the current educational landscape. As you can see, we are support from the corona pandemic, and all science teachers should prepare their online teaching suddenly. So, and secondly, the government said science teachers must adopt more edutech and high-tech technologies in their science lessons, and science teachers um, uh, science teachers should do scientific inquiry and modeling activities in their science classrooms. So for the research, uh, it is evident for science teachers facilitating competencies plays a critical role in enhancing their students' scientific abilities. So our research questions is, what are the perceptions of secondary school science teachers regarding improvement of students' scientific competencies based on the KSES? The KSES is for the national documents, for national reform educational documents. So the first question is, to what extent are science teachers interested in their teaching competencies? And the second one is, to what extent do science teachers demonstrate self-efficacy in their teaching competencies? And the third one is, to what extent do science teachers implement their teaching competencies? So let me explain our survey framework. We did online survey, and you can see here there's a 5 competencies in the national reform documents. There's 5 competencies for students. It's not teachers. There's a there's scientific inquiry, scientific thinking, communication and collaboration, and information processing and decision making, and lastly, lifelong learning abilities in hyper-connected society. We are more curious about teaching competencies of science teachers. rather than students' competencies. So we surveyed three ways for interest and self-efficacy and their implementation in science classrooms. So we did online survey. There's 38 statements on the 5 competencies from KSES documents, and each addresses 3 domains of concerns: interest, self-efficacy, and implementation with the 5-point Richter scale. And we did content validity check with 3 experts. And our survey contains the basic information and the questionnaires. And you can see the basic information of our participants. There are 107 participants in the survey. Uh, the gender ratio is quite balanced, but slightly more females in the survey. And you can see their teaching experience is mean of their teaching experience is 12 years. Um, and let me show the result of our survey. You can see there's 2 big characteristics in these pictures. And firstly, you can see there's a green bar with is for interest, and the red one is for self-efficacy, and the orange one is implementation. You can see the interest is the highest, and decrease to self-efficacy, and the implementation is the lowest. The tendency of this decreasing is common in all 38 sentences. And you can see the highest scores on the communication and collaboration competencies, and the lowest scores were the lifelong learning abilities in hyper-connected society. I will show more details in the slide. Because we have 38 statements in our questionnaires, it's quite long, so I will just show you the sub-competencies in the KSES documents and the teachers' scores on each abilities. The first thing is there's scientific thinking abilities, and you can see there's 4 sub-abilities here. There's logical thinking, critical thinking, creative thinking, and mathematical and computational thinking. You can see here the first 3 ability, the teacher scored higher. Then you can see the ST7 on assessments on ST7, the score was lower. It's for the computational thinking. All science teachers are not familiar with the making algorithm with computers on natural phenomena. So, and we can see the next one, the scientific inquiry competencies. Teachers, scientific inquiry competencies. And you can see there's 6 sub-competencies. The, 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 the first sub-competency is identifying a problem, making and applying models, and designing and conducting experiments, implementing and transforming data, and engineering design, and lastly, explanation and scientific argumentations. And you can see there's lower scores on engineering design and making scientific argumentations. So this means for engineering design, very low average. So for the statement SI9, it means the considering a variety of sources to solve problems, and SI10 is for breaking down big problems into smaller sets, and the SI11 is for visualizing the problem-solving process. the students are not familiar with these engineering design abilities. And the next facilitating competency is on communicating and collaboration ability. Uh, you can see the expressing idea is higher, and another, the generating rules, working collaboratively and monitoring group was lower than the expressing ideas. And it is belong to communication abilities, and the other three is belong to collaboration abilities. The new reform documents now places a new emphasis on collaboration, revealing three sub-competencies, but science teachers are not familiar with these competencies and have limited skills to implement them in their science lessons. And fourth, facilitating competency is on information processing and decision-making ability. You can see the searching and selecting information gets higher scores, but another sub abilities like producing information, evaluating information, exploring alternatives, and judging value gets lower scores. And you can see the self-efficacy was especially low in ID4, and their implementation was especially low in ID6. And you can see this was for evaluating information, and ID6 is on exploring alternatives. So low level of self-efficacy on assessing their reliability of information source, and low level of implementing on exploring alternatives and judging their values. And the last facilitating ability is on lifelong learning ability in hyper-connected society. Maybe some of you have questions on why this ability is included in science competencies, but in Korea, we want to prepare for the next generation and future generations. So the reform document includes this kind of abilities in the document. And as you can see, the score is really lower than any other competencies. And you can see the LL2 is on making relationships, and LL4, the human clouding, is especially lowest scores. So in some, we have two discussions. The first one is teachers' knowledge on the new competencies. The teacher showed low level of interest and implementations, especially on to make a model and engineering design, computational thinking, response to the hyper-connected society. And it's all these all abilities is quite newly adopted in the reform documents. So the science educators need to put more research effort on improving understanding of teacher competencies in the KSES and teaching and learning strategies for implementation. And the second discussion is on making and preparing doing science in classrooms. The we we saw higher level on the aspect related to data interpretation, but there is imbalance between interest and implementation. There is higher interest and self-efficacy on designing and conducting experiments, but low level of implementations, and this shows limited chances for experimentations. So to enlarge the opportunity to experiencing the whole process of problem solving, it can be considered to implement project-based learning, self-directed inquiry learning, and inquiry-based learning. So, and we can consider ways to enhance teacher interest and promote implementation in expanding teaching and learning strategies. Uh, I was so nervous that uh, it's uh, that's it, and time is limited. Thank you.
Thank you.